Hello there, and you find me back in the Your Maths Tutor online classroom taking a look at question 10 from paper 2 of the 2019 higher level maths exam. Quite a few of my students have asked me about this question, so I thought I'd put together a video showing you how to work through to the solution. It's caused some confusion, and once we get to the end, I think you'll see why. Well, the first part is fairly straightforward. I won't read the question to you, but we need to check that x plus 3 is a factor of this quartic. We can write down the coefficients, 3, and 1, negative 8, negative 6. And because we're dividing by x plus 3, check negative 3. So bring down the 3. Negative 3 times 3 is negative 9. 10 add negative 9 is what? Negative 3 times 1 is negative 3. 1 add negative 3 is negative 2. Negative 3 times negative 2 is positive 6. Negative 8 add 6 is negative 2. And finally, negative 3 times negative 2 is positive 6. Add those two together, and we end up with 0. So far, so good. And I would have to write down that because the remainder is 0, x plus 3 is a factor. Remember your marks for communication. Now I have the coefficients. So I'll have 3x cubed plus x squared minus 2x minus 2. And I need to factorize this. Well, I've got some options now for the numbers that I can use to test using synthetic division so I can determine what other factors are. Well, rather than having wild guesses, I can look at the number on the end. I've got negative 2 there. So chances are that my factors are going to be 2 and 1 that I can test with. So let's try an easy one. Let's see, remember from the remainder theorem this is, that if, you remember the remainder theorem, if x minus r is a factor, then f of r will equal 0. So, and again, just rounding on this negative 2 at the end, I'm going to try 1. So let's have a look. Let's see what f of 1 is. That would equal 3 times 1 is 3, plus 1 squared is 1, minus 2 times 1 is 2, minus another 2 is 0. So it's looking suspiciously like x minus 1 is a factor. So let's, for the next stage, let us divide this cubic by x minus 1. So I'll write down the coefficients of the cubic, 3, 1, negative 2, 2. I'm going to divide that by x minus 1. Pick 1 there for a table. So bring down the 3. 1 times 3 is 3. 1 plus 3 is 4. 1 times 4 is 4. Negative 2 add 4 is 2. 1 times 2 is 2. And here we are, a belts and braces check that x minus 1 is a factor. Negative 2 add 2 is 0. The remainder is 0. Therefore, x minus 1 is a factor. Now, finally, when we have a look at these coefficients of quadratic at the end, 3x squared plus 4x plus 2, having a look at this and checking using the discriminant b squared minus 4ac that we can actually factorize this into two sets of brackets. In other words, does this have real roots? Squinting one eye at this, when I scribbled this down on a piece of paper earlier, I could see that I don't think it does have real roots. So let's just double check that with the discriminant. So we have b squared, which is 4 squared, 16, take away 4 times 3 times 2. Well, immediately I can see that 4 3s are 12 times 2 is 24. So this is going to end up being less than 0. So I can't factorize this. So the final answer to the question is fully factorize 3x to the 4 plus 10x cubed plus x squared minus 8x minus 6 is going to be x plus 3, 3, x 1, finally 3x squared plus 4, 2. There's the final answer. And that is the point where quite a few of my students were confused, which kind of leads you up the path to thinking that ultimately you'll end up with 4 sets of brackets because it's a Quartic. Unfortunately, you don't. And it'd be interesting to see what the commentary is once these exams are marked. And I'm surprised this didn't cause more outrage than it did. 1 or 2 of my students got partway through this question and gave up at the end, and I can understand why. So there we are. There's a solution to this factorising question. And you can see that you can't actually fully factorise. Now, I'd be interested to hear your comments. Do you think that was a trick too far, not being able to fully factorise that question? Well, in a way, I probably do. It's a bit like testing somebody on how to make a cup of tea, but I've hidden the tea bags and I've put the milk in a different bottle. That's fair enough, as long as you're prepared to tell people that's what you've done. This question specifically says factorise fully. And, well, you can up to a point, but because it's a Quartic, you'd be forgiven for thinking that you could stick it into 4 sets of brackets. Well, here comes a shameless plug. My name's Ian Wild, and I'm your maths tutor, and I use this, the online classroom, for teaching students across Scotland. I'm available for face-to-face teaching in and around Edinburgh. If you or somebody you know needs help with maths or physics, then please do visit me at https://yourmathstutor.info. And feel free to get in touch. Thank you. Bye-bye.